Throughout our previous discussions, our focus has been primarily on APK files. Hello everyone, welcome back to a new video. In this video, we'll unravel the intricate process of constructing Android apps. It's crucial to comprehend the inner workings that lead to the creation of these APK files. When a developer engages with an integrated development environment, IDE, like Android Studio, they typically undertake the following steps at a high level. For a more profound understanding, I invite you to watch this video. In it, I've taken the initiative to craft a prototype Android application using Android Studio. This video reveals that an Android project generally encompasses Java source code, which is subsequently compiled into a binary form called classes.dex. Additionally, there's the binary representation of the Android manifest.xml file and various other resources that harmonize during the compilation and packaging phases. Upon reaching completion, the app necessitates the developer's digital signature for verification. At this point, it becomes primed for installation and execution on a device. While this may seem straightforward from a developer's perspective, it encompasses intricate processes behind the scenes. Let's delve into the mechanics of the entire build system to gain a more comprehensive insight. The opening act of the build process revolves around compiling essential resource files like Android manifest.xml and other XML files. These files are pivotal for crafting the user interface of activities. The mastermind behind this operation is none other than AAPD, Android Asset Packaging Tool. This magician conjures up a file named r.java, home to a set of constants that serve as our gateway to referencing them in our Java code. In case the project incorporates .aidl, Android Interface Definition Language, files, these undergo a transformation orchestrated by the AIDL tool. It metamorphoses them into .java files. AIDL files commonly find their purpose when we grant permission to clients from diverse applications to tap into our service for inter-process communication, IPC, and when the need arises to navigate the intricacies of multi-threading within the service. With our Java files fully prepared for compilation, we move forward. The Java compiler, commonly referred to as Java-C, undertakes the task of processing these Java files and generating corresponding class files. As we make progress, the subsequent step entails the transformation of these .class files into .dex files. This conversion process is performed using the DX tool, although in recent times, D8 is more commonly used for this purpose. The result of this stage is the creation of a solitary DX file, denoted as classes.dex. Subsequently, the classes.dex file produced in the preceding phase, in combination with resources that remain uncompiled, such as images, as well as compiled resources, are ushered into the realm of the APK Builder tool. Here, these components are methodically woven together, culminating in the creation of an APK file. To install the APK file on an Android device or emulator, it's essential to sign it with either a debug or release key. During the development phase, the IDE signs the app with a debug key to facilitate testing. This signing procedure can also be performed manually through the command line, utilizing tools like Java KeyTool and Jar Signer. As the application nears its final release, it must be signed with a release key. Once the app is signed with a release key, it needs to undergo alignment using the Zip Align tool. This alignment enhances memory optimization while the app runs on the device, ensuring smoother performance. All these processes unfold behind the scenes to generate the APK files. In our upcoming video, we'll delve into the creation of DX files through command line operations. Until then, farewell. If you have any questions or doubts about this video, feel free to share them in the comments section below.